If you do miss any part of the lecture today, or you just want to go back and watch it, you can do so under the Canvas tab, or all lectures are being live streamed on the YouTube. So if you miss it, feel free to go back and take a look. Here we go. Let's go square root, negative square root. Four ninths. Let's go square root of negative 169. Let's go 8 to the 2/3. And let's find the domain of y equals square root 8 plus 6x. Go. Start with those four. Oh yeah, call Marlene and ask her if they would store it for us. All right, let's go. Where are we at? Where did my water go? All right. So we got a lot of people who said call on. They're ready to go. So let's ask this. Um, let's ask this. Let's start with Will today. Will, of these four, how many do you feel like you have? On the number from 1 to 4, how many do you feel like you got for sure? Maria, how many do you feel like you got for sure? All right, Maria, give me the three you're certain of. We're gonna go A, B, C, and D. Go ahead and type them out, Maria. Which ones do you feel confident in? A is -2/3. Absolutely. In order to do this, you take the square root of 4 over the square root of 9, and you're going to get square root of 4 is 2, so that's -2. Square root of 9 is 3. That's -2/3. Excellent work, Maria. Great job. B is undefined. B is undefined. Very good. A negative times a negative is going to be a positive number, so there is no way to get to a -169. The only way to do that is to use imaginary numbers. That comes up later in the course. We haven't done that yet. All right. So C is 4. Great answer for C, Maria. What is this? This is the cube root. This is the cube root of 8 squared. The cube root of 8 is 2. 2 squared is 4. Okay. All right. Maria, you don't have D, or you're just not confident in it? All right. I'm trying to remember who else I saw said they were ready to put them in. Um, I believe Tabira was on that list. Tabira, do you have it? Nice. Excellent. Good job, Tabira. -4/3 to infinity. You're a rock star. I don't care what your mama says about you. Subtract 8, and I'm sure she speaks highly of you, by the way. I was just joking. Divide by 6, divide by 6. X is greater than or equal to -4/3. So we write that with -4/3 to infinity. Love what you did right there, Tabira, that you put the bracket on the -4/3 and you put the infinity with a parenthesis. Nice work. Overall, great answer. Great answer. And again, just so that we're straight, this is the type of work that I'm going to need to see on test 5. This is the type of work I'm going to need to see. I don't want you to say 8 to 2/3 equals 4. That's it. If you do that, I'm telling you, I'm not giving you credit.
I have a
Some
question.
people have lost a lot of points because you didn't show any work. Yes, please. Go ahead, baby.
On C, So I didn't do it that way.
How did you do it, sweetie?
I put the 2, like the squared, underneath the square root, and then I squared 8,
So
and
the
then I
other
took
way
the
to do
2.
it would be to do 8 squared first, and you get 64. And then you take the
Mm-hmm.
cube root of 64 and you get 4.
Yes.
That is a totally
Okay.
acceptable way to do it as well.
Okay.
Just make sure you show that. You see what I'm saying? As long as I see it, I'm cool with it.
All right.
It's when I don't see anything that I just assume the worst. All right. All right. Let's go here. Let's go here. LETSGO. Let's go. Let's go. Let's go here. We're going to call this next level. We're going to call this next level. This is next level. This is next level. Here we go. And then let's go x to the 4/3 squared times x to the 1/5. Let's go. We're feeling it today. We're feeling good today. Let's do this. All right, where are we at? Will, Rolande, where are we at? Rolande, you close? All right. Well, I'm assuming she's not here. Eric. Eric, you got both of those, huh? Eric, what is up, man? Eric's like a superstar. Eric, what did you get for the first one? Explain it. Well, that's gonna be a little hard to do. Not quite though, Eric. It's not 1/4. It's actually negative 1/4. Um, let's take a look why. Let's take a look why. Um, the negative is not part of the exponent. So that's the first thing you recognize there. The negative is not part of the exponent. So the negative's on the outside. And then what you're going to have is the fifth root of 32 raised to the negative 2. All right. So what you're going to have here, the fifth root of 32 is 2. So this is minus 2 raised to the negative 2, which is minus 1 over 2 squared, which is negative 1/4. So for the first one, Eric, it's negative 1/4, not positive 1/4. If, and I'm going to put this in a different color, if it were this, it would be positive 1/4. If the negative were included, it would be positive 1/4. All right, Wilton, what you got? How do you know the fifth root of 32 is 2? If you break, and we're going to do this later on today, but if you break 32 down at 16 times 2, 16 is 8 times 2, 8 is 2 times 2 times 2. If you do prime factorization, 2 to the 5th is equal to 32. And we're gonna do some of that later on today.
Okay. I didn't do the first one correct, but like what you showed us and what we will do all the time. Like I got the same answer, just not those steps.
What did you do, baby?
Like I put the negative fifth root of 32 squared underneath a fraction, so it's like 1 over that.
Oh, that's fine. That's fine.
Okay.
You just moved it to the bottom sooner than I did, but it's okay.
Okay.
All right. Thank you, Tabira. All right. Who's got the next one? Somebody have a question? Go ahead. Somebody got a question? Go ahead. All right. Who's got the next one? Anybody? Who's got it? Come on. Okay, what you got, Cayenne? Well, let's take a look. This is x to the 4/3 times 2 is equal to 8/3. So this piece is x to the 8/3 times x to the 1/5. Okay. 8/3 times or plus 1/5. Multiply up, multiply over. 40 plus 3 over 15. So this is x to the 43 over 15. Okay. Great job, Cayenne. Excellent work. Up, over. Up, over. We use it all the time. We use it all the time. Let me ask you a question. Find A such that x to the A times x to the 3/4 equals x to the 3rd. What would A be? Yes, Cayenne. It is 9/4. How'd you do it? Exactly right. A plus 3/4 equals 3. And then you just subtract 3/4 from both sides. A equals 3 minus 3/4. Multiply up, multiply over. 12 minus 3 over 4. So, very similar problem. It just requires you to go about it a slightly different way. Questions on that? Questions on that? Questions on that? Find A such that x to the A is equal to the 7th root of x to the 6. What would A be? Anybody? Alexis? What would A be? If you hurry, Alexis, you might be able to beat Maria. Go ahead, Maria. If you got it, go ahead and say it. A would be 6/7. Very good. Okay. Excellent. Any just slightly different ways that I can ask the same questions is all I'm getting to. Slightly different ways that I can ask the same questions.
I don't understand that one.
Well, so here's the thing. When we did 8 to the 2/3, you understand that that's the cube root of 8 squared, right?
Yes.
So my question is this. If I gave you this, what exponent would you use there?
What exponent?
Yeah.
2/3.
That's all I'm asking.
Okay.
It's just a different way of thinking about it. See, if I say 16 to the 1/4, you know that's the fourth root of 16 to the first. Right?
Yes.
Well, if I say square root of 25, that's 25 to what power?
What do you mean? Like, to what?
25. What power do you have to raise it to make it square root of 25?
What power would I raise it to?
Yeah.
1?
Well, no. Can't be 1. 25 to the first is 25. All right, let me ask you this. What's 36 to the 1/2? What does that equal to?
Square root of 36, which is 6.
All right, so square root of 81 is equal to 81 to what power?
2.
No.
1/2?
Yes, 1/2. Look, you're going this way. I'm just asking you to go backwards.
Okay.
Right? Like if I say to you x to the 7/12, you know that's the 12th root of x to the 7th, yes?
Yes.
Okay, so then if I got rid of this and made this the 15th root and made this 11, what would this exponent be?
11/15. I mean 15.
11
Yeah,
15. That's all. That's all you're doing.
Okay.
It's just a different way of writing it. But you need to be able to see it. I mean, like you need to know that's what it is. Wilton, are you good or you still have questions? So that it's not. There's nothing to it. There's nothing to it more than what it is. But you see, it's just a different way to ask the same question. And my point is, I can ask you the same questions in a lot of different ways. Okay. And I want at least all of you who are watching this to know that I can ask it in different ways, and not only know that I can, but to expect that I will. Okay. All right. We're moving on. Questions, comments, concerns? I can't see who else is in the damn chat. Rolande, we good? Maria, we're good? Daisha, we're good? Daisha, Rolande? Daisha, Rolande? Debira, I see you. Go ahead. What you got? Give me a second. Got to. All right. Let's go here. All right, let's go here. We're moving our discussion into how do we break down things like the square root of 32. All right, you see square root of 32. How do we break down things like the square root of 32? And I'm going to need to see your work on this. Okay. If you type square root of 32 into a calculator, you're going to get 5 point something. I don't know what it's going to be. All right. It's going to be 5 point something. All right. I'm not interested in this decimal approximation. What I'm interested in is you getting to 4 square roots of 2. Now, how do you get to 4 square roots of 2? Well, and you're going to have to show this. Like now more than ever, you have to show this. Square root of 32 is 16 times 2. 16 is 4 times 4. And you're looking for perfect squares. So this is a perfect square. This 4 comes on the outside. And you get 4 square root of 2. Now, you get the square root of 2 because 2 is not a perfect square. And there's no other 2 in there. So that just stays on the inside. Okay. So groups of 2. Groups of 2 go to the outside. Non-groups of 2. Stay on the inside. Okay. Any questions on that? The idea that's being established there. Any questions on the idea that we're establishing there? All right. You try square root of 50. What will square root of 50 be? All right. When you have it, just go ahead and type done. When you have it, type done, please. All right. Will, what do you got? And you can just use S to represent square root. So as we do these, if you want to represent the square root, just put S. Nice. Okay, nice. So 50 is 25 times 2. 25 is 5 times 5. So those will come on the outside. And you'll get 5 square roots of 2. All right. Let's try this. Let's try square root 24. Let's try square root of 72. I'm sorry. Let's try square root of 243. Let's try those two. Let's try those two. All right. If you have both, go ahead and type in done. All right. Cayenne, take the top. What did you get? 2 square root of 6. Very good. So 24 is 4 times 6. 6 is 2 times 3. 4 is 2 times 2. Now, again, we're looking for groups of 2. So we're going to pull this 2 out, and we're going to get 2 square root of 6. Once these come out, these two are not the same, so you have to leave them under the square root. So 2 square roots of 6. Very good. All right. Square root of 243. Square root of 243. Tamira, yeah, go ahead. Nine square root of 3. Very good. So this is 9. Well, this is 243 is 81 times 3. 81 is 9 times 9. Once they're a pair, you can just take the pair out. You don't need to do 3 times 3 and 3 times 3. You're just looking for a pair. The minute you find a pair, you can go ahead and take those out. So 9 square roots of 3. All right. Any questions?
Would you ever have it where the other number, so like you took 81 out, and what if that 3 could be broken down into another perfect square, or would that never happen?
So, no, actually, very good question. So it certainly could, depending on how you do it. For example, let's say I give you square root of 100. And you say, well, 100 is 25 times 4. Well, then 25 is 5 times 5, so that comes out. 4 is 2 times 2, so that comes out. And then you end up getting 10. All right?
Okay, cool.
Now, I'll tell you the other place that I've seen this. And let me see if we've done it yet. The other place that I've seen this is on this one. Let's everybody try this one. And I'll show you what I see a lot of. Everybody try square root of 72. Go. All right. Type done when you have it. All right. Will, what did you get? Yes, it is 6 square roots of 2. Now, the way you break this down is, the way I do it is 36 times 2. 36 is 6 times 6. And that comes out. So that is 6 square roots of 2. Now, one of the things I see a lot of people do, Cayenne, this takes you back to the kind of the question that you had, is I'll see people who do 72 and they'll do it 9 times 8. A lot of people will snap out 9 times 8 right away. And then they'll say 3 times 3, and then they'll pull the 3 out. And they'll call that 3 square roots of 8. All right. While this technically is not wrong, because what you've done is kind of correct, it's not reduced into its simplest form. The 8 can be broken down again, which is 4 times 2, which is 2 times 2. And then the 8 comes out as 6 square roots of 2. Okay. So, Cayenne, I think that was kind of what you were asking. Is it possible that the number that you have left can be broken down even further? And that answer is yes, it can, depending on how you go about doing the problem. All right. All right. Question. Let's go square root 48 x to the 12th. Square root 48 x to the 12th. We're gonna put a prize pack on this. Anyone who gets this problem right, usually the prize pack goes to one person. Today, there's multiple winners of the prize pack. Anyone who gets this correct, go to Dairy Queen and tell them I said give you a free Blizzard. Your choice, your size. Just go to Dairy Queen and tell them I said to give you a free Blizzard. All right. Everybody who gets it right gets a free Blizzard today from Dairy Queen. Okay. Alexis, how we doing, baby? I haven't seen your name pop up lately. All right. Are you good on this one, or are you just good on all the other ones we've done? All right. All right. I feel you, though. Let's see here. Eric. Eric. We haven't heard from you lately. All right. All right. Well, Tamira, go ahead, baby. What'd you get? Take yourself off mute and say it.
I got 4x to the 6 times the square root of 3.
4x to the 6. All right. So walk me through it. What did you do?
First I found what two numbers could get 48 and become a perfect square.
What numbers did you choose?
16 and 3.
All right. And then 16 is 4 times 4?
Yes.
All right. So that 4 comes out. That square root of 3 is left over. Very good. How'd you deal with the x to the 12?
Well, it's 12 x's, and since it's a square root, 2 of the 12 come out. So you would take
1, 2,
2
3,
from
4,
each
5,
group.
6, 7, 8, 9, 10, 11, 12. Now, as we look at those 12,
You take out a couple, a
take them
couple
out
of
in pairs. Yeah, 1, 2, 3, 4, 5, 6. There are 6 pairs of x's. So your final answer is 4x to the 6 square root of 3. Tabira, nice work, baby.
Thank you.
Nice work. Get yourself a blizzard today, okay? Do you eat ice cream, Tabira? Probably not.
Yes, I do.
Okay. What's your favorite blizzard?
I never been there before.
Damn, girl. We need to meet and I'll buy it for you.
Okay.
Just in case you don't like it, then you ain't wasted your money on it.
All right.
All right, we're gonna do that. I'm not setting a time though, because that actually makes me have to go buy it. And I'm just telling you that we're gonna do it eventually. All right. Any questions on that? Any questions on that? Going once. If you have a question, start typing. Going twice. All right, let's try this. Let's try this. We're going to step our game up. We're stepping our game up right here. We're going to go square root 200, x to the 10th, y to the 15th. Go. Emily. All right, who's got it? Will thinks he got it. Tabara says she got it. Cayenne says she's done. Alexis? Alexis, is this your moment? Are you coming out of retirement, Alexis? Alexis? You're dead, man. All right. Cayenne, go ahead. What'd you get? This one's tough to type in. You might want to just say it. Oh, or you just do it that way. We got 10 x to the 5th, y to the 8th, square root of 2. I don't think we want 8, Cayenne. Let's take a look. 200 is 2 times 100. 100 is 10 times 10. So we're going to get 10. Now, how do I deal with the exponents? Here's the easy way to do it. You take the x to the 10th. You deal with the exponent. Take 10 divided by 2, you get 5. All right. Take 10 divided by 2, you get 5. The remainder is 0. So that's going to be 10x to the 5th. You take 15, divide that by 2. You get 7 with remainder of 1. So it's going to be 10x to the 5th, y to the 7th, and the remainder is going to be square root of 2y. All right. So that's your final answer. 10x to the 5th, y to the 7th, square root of 2y. Yeah, well, yes, well, it would be. Well, it would be 2y. I think Cayenne wrote down 16 and not 15. That's my guess. Positive intent, Cayenne. I knew you knew. All right, questions on that? Questions on this? Going once? Going twice? All right, let's ask this. Let's ask this. If I give you a right triangle, let's say that this is 12 and this is 18. What is this side? Go. Now you got cereal. All right. All right. Who knows? This is taking you back to like 7th, 8th grade, probably. If you're from Haines City, maybe 12th grade. Could be 11th if you were in the advanced class, I guess. Who's got it? Tabira is kind of like geometry, although this is the only geometry we do. So you may remember this is what's called the Pythagorean theorem. Pythagorean theorem says that if we have a right triangle and we have three sides, that a squared plus b squared is equal to c squared. So in this case, we would have a squared plus 12 squared equals 18 squared. Okay. So the a squared plus 144 equals 324. We would subtract 144, subtract 144. We would get a squared equals 80. And so that a is the square root of 80, which if we break that down is 16 times 5. 16 is 4 times 4. And we get 4 square roots of 5. All right. Oh, shit. My bad, people. $180, which is 80 times 10, which is 16 times 5, and 10 is 5 times 2. So the 4s come out, the 5s come out, you get 20. No. $18 times 10, which is 9 times 2, and 10 is 2 times 5. So this is 6 square roots of 5. My fault. Six square roots of 5. Thank you, Maria. Wilton, it's a right triangle. A squared plus b squared equals c squared. All right, so I plug in 12, I plug in 18. People will ask, how do I know that 12 is b? It doesn't matter. You can make it a and it's the same thing. Know that the longest side is called the hypotenuse, and it's always directly across from the right angle. That side must always be c. So subtract 144, you'll get 180. And then take the square root of 180, you'll get 18 times 10 and 9 times 2 and 2 times 5. All right. All right. With that, we're going to stop here for today. Just a couple reminders. Please, you should be through 8.3. You should be through 8.3 on the homework. Make sure it's vitally important that you're getting through the homework as we do this, as we work through this stuff together. Okay, vitally important that we get through the homework, because it is through the homework that you're going to get practice. Because we're not, we're not going daily in class. So please make sure you're practicing on your own. In addition, again, just a reminder that all the lectures are being live streamed on YouTube. So if you have a problem, you can always go back to YouTube and watch it. You can go to the Canvas conference page after it's done, and you should be able to watch the recording of it later. If you have any questions, you can email me. I am available to you, sdrier@polk.edu. You can find me on Snapchat at sdrier2019, or I send an email that has my phone number in it. You can give me a call. Okay. If I haven't done the verbal assessment, we need to get on that. I've got somebody to call right now, so I'm going to call them in between classes. Send me an email, shoot me a text, let me know what time is good for you, okay? Any questions? Any questions? Going once? Going twice? All right, we are sold. We will see you back here next time. Until then, take care of yourself and each other. Stay safe, everyone. Love you.
The only person in this conference. The only person in this conference.
Hello?
You are now muted. You are now unmuted.
Hey, what's up, Gavin?
Not much. Just doing some other bits of school.
I'm going to put you on mute for a second, all right?
All right.
You are now muted.
Hey, girl.
Hey.
All right, so I'm assuming that the stuff that you sent me was not your scratch paper from the test. That was you going back and looking at it?
No, that's what I did on the test. I wrote it all out.
Yeah, but how did you get, I mean, you got a lot of the answers right.
What?
On what you wrote me, you have a lot of the answers that are kind of correct.
I don't know. I started, but I think I took a lot of time writing them, and I had got up and everything. So I don't know.
I mean, I guess what I'm saying is, as I look at your score wasn't very good. You know what I'm saying? Like, I mean, what did you get on the test? Do you know?
I think it was like a 44 or something.
Right. So generally the verbal assessment goes with, generally what I do is I look at your results and I see which ones you got right. And then I compare that with your work. And, that's kind of how that whole system goes down. Freaking shit. Hold on for a minute. Let me try to find you. You're Monday, Wednesday, right?
Uh-huh. And you said it's no final?
No, there's no final.
So this stuff is going to be our next test? Or
Yep.
that's it?
Yeah, it's going to be the next one.
Okay, well, when you're done, I need help with a couple of questions.
Well, I've got a class at 12, so I don't know.
Oh, okay.
All right, let's see here. All right, I'm going to ask you a few questions, okay?
I have to write them down?
Yeah. All right. X squared plus 3x minus 4 over x squared minus 1. Simplify that.
X squared plus 3x minus 4 over x squared minus 1.
Yep. How would you do that?
X plus 4 and parentheses, and then x minus 1 over x minus 1, x plus 1.
Okay.
You want me to cancel the
Yes.
2?
If you can cancel, let's cancel.
So x plus 4 over x plus 1.
Good. Good. All right. All right. Let's go. Let's go 2 over x plus 3 over x plus 2. Let's add those together.
I don't know how to do that one. The last one don't even got an x on it.
What's that?
I don't know how to do that one.
Okay. All right. Let's go here. Let's go. Let's go. Let's go 1 over x plus 1 and 1 over x minus 1.
1 over x plus 1.
And 1 over x minus 1.
You cancel the x's?
No, you cannot cancel the x's. You gotta add them together and then do keep, change, flip. Does that help? Not really.
Mm-mm.
All right, here, let me give you this one last one. Let's go x plus 7 over x squared plus 9x plus 14. Simplify that.
I want to say x plus 2. Hold on. X plus 2?
X plus 2. Let me see your answer. Oh, you never actually wrote it. You just wrote it as... All right. It's 1 over x plus 2, Ladecia.
Why?
Because the x plus 2 is on the bottom.
Oh.
All right. All right, girl, we're done. We'll need to chat to go over all the other questions, though, okay? But I've got class in a minute, so I need to get going.
Okay.
All right? Send me a text. Let me know a good time for you, okay?
Okay.
And we'll do it. All right. Bye, girl. See you. Bye.
You are now unmuted.
All right, it's 12 o'clock. Straight up and down. Let's do this. Morning, Julio. Good morning, Dylan. Good morning, Ellie. Ellie, why don't you have your microphone turned on? How am I supposed to talk to you with no microphone? Jan, it's good seeing you again. Harriet, much love for you. Because you don't understand what? The microphone or the material? You click on the little phone, and then when it asks you, you say microphone. Doesn't yours come up and say listen only or something like that? All right. Well, let's get started because, there's some people who are impatient. All right. Here we go. Just want to make sure you can see the screen. Make sure you can hear me okay. Go ahead.